All right. My history before I joined the team back in March of last year, I was about eight and a half years in law enforcement, which I know that's kind of a unique jump over to engineering and data analytics. I served for Greenville County. I was a lieutenant for the Department of Public Safety. And after I went back and got my master's degree, and in that started focusing on data analytics, and had worked at this plant back in 2007 as a machine operator. And I know with data science and this and IoT, it's very important to have that operator experience and trying to really, create some value out of what you're trying to accomplish with the software, and because there can be a significant disconnect if you don't. Here's our plant, and we like to say that we're a family. Actually, out of those 50 employees, about 25% are from other countries. So we pride ourselves on being diverse, and we have a pretty good representation throughout the world. We've been in operation for over 20 years, and we really want to try to lead and show what's possible in this arena. So here's some mega trends from Continental, from corporate. And so we're big on safety, information, environment, affordable mobility. And here locally in Fountain Inn, this is actually what we produce. We produce a metallic substrate catalytic converter. It then gets shipped to other suppliers who apply the special metals that go into the catalytic converter. So we knew what we produce, and then how we produce it. We have assembly line production that then goes into a batch oven process. But during this journey, we started asking ourselves, why do we produce what we produce? And that's one of the key things in any kind of strategy, any kind of vision, is understanding why. Because as Nietzsche said, if we can understand the why, we can overcome any how. So we started questioning ourselves on why is it that we do what we do? And ultimately come to the conclusion that we reduce emissions in order to try to create a more sustainable future. Here's some research for this year that was pretty shocking, even though we've had a lot of great progress. And we had the clean tech, the innovation companies coming out that, with Silicon Valley, I think in 2007, we've had a lot of increases in solar, wind generation, but yet it's continuing to rise, the emissions. So, in the automotive industry, we've made a big commitment towards going towards electrification. Here's some data we pulled from the Department of Energy showing if we go from gasoline straight to all electric, there's still a 50% emissions because of the electricity that it takes or will require to charge the batteries. So is this really, is this enough? And are we basically shifting the burden to the energy sector? That's now going to have to produce that extra supply for the batteries, to charge the batteries. So here's some projections through 2050 that we found. And so we have the Internet of Things, which is expected to grow by 10 times according to the United Nations by 2030. So we'll have more and more devices that are connected. In addition to the electric vehicles, and we also have emerging countries, third world countries that need access to electricity, and all of that is going to, impact the grid and the energy suppliers. And of course, they face significant challenges. I mean, we know it's almost very, very difficult task to predict solar, predict wind, because there's so much variation that's occurring real time. And so in order to predict how much you're going to be able to generate would be very, very challenging. And on the flip side, the demand side, you have so much, variations with the demand. I remember last year doing this and how we've kind of come to this. We got hit with a hurricane, and we actually shifted our production schedule because of that hurricane. Well, if I'm the energy supplier, I may not realize that we normally need this amount of energy on a Monday. But if we shift that schedule, not work Monday or Tuesday, then the energy supplier may not know that. So on a local level, some other interesting research that we found was IBM had published that a 5% efficiency increase in the U.S. grid alone is the equivalent of 53 million fossil fuel vehicles off the road. Also that there's, because the energy suppliers actually overproduce in order to be able to meet that demand, that some of that overproduction is actually wasted because it's not used. So it just escapes out, and there's inefficiencies that leads to enough energy to power 3 countries, Canada, Germany, and India for an entire year. All right, so moving back to our local project, what we're here for. So our corporate laid out this framework is to, we're to capture energy data at the input of the location. So our goal for last year was to go to level 1. We'd have install 3 meters that could capture the data every 15 seconds. The following year would be level 2, then level 3 to kind of aggregate down that energy monitoring. Ultimately, with the end goal within the next 3 or 4 years to get to level 4, where we're monitoring energy at the machine, at the production line, and actually be able to see how much energy goes into producing 1 unit. So our core values, we knew it would be risky, going just straight to level 4, but that's what we chose to do because we felt there would be more value in level 4 monitoring than just taking the standard course. And as Einstein said, try not to become a person of success, but rather let's become a person of value. So can we create value by going to level 4, making a risk, understanding that corporate may not accept it? That's what we chose to do. We installed an open source building management system that allows for continuous development programming, so we can actually, schedule our HVAC units and optimize them based on our production schedules. And that leads us into our pilot project with MindSphere. The Continental, with all the plants around the world that we have all sorts of different vendors. So we were able to select the type of meters that we want to produce, and we have the goal of being able to feed that and give that data to corporate so they can analyze that. And we felt like MindSphere would be a good fit for us because of their experience in software and hardware automation. So we installed 45 CT meters all throughout the plant. We ran the wires ourselves, our local team. They were split core CTs, 3-phase monitoring, and we hope to in the future be able to predictive, have preventative maintenance. So if we lose a phase, we could have some kind of real-time alert. Now, our evaluation with corporate was on December 18th. And we made our presentation, and actually Siemens, they weren't able to get the software side implemented, so we had all the hardware there. And from day one when I started, I was like, hey guys, we got to start looking at these Raspberry Pis, Arduinos, and all these cheap sensors that are coming out, because that's going to be the future. You can buy a $35 Raspberry Pi PC, which is ultimately what we did. We actually had to, I was real proud of our team because I came in this morning trying to figure out how are we going to get this implemented before, we had like 4 or 5 days. And my team actually went out there and put a Raspberry Pi, connected the controller into the Raspberry Pi, and so we created a VPN in, so we were able to display our monitoring real time to corporate. So we kind of overcome the obstacles, and so it was just a real proud moment that if we kind of say that we either find a way or we're going to create one, and that's ultimately what the team did in this situation. Now, with that said, we actually failed our green plant assessment, and so because we didn't check the box, we didn't get to level 1, and there were some other issues that we had to work through, but we didn't receive it. But they gave us another chance. They said, all right, 30 days, we'll reevaluate you. You guys, we love what you guys did, but get those meters installed at the level 1 level. So that gave us some more chance to actually do what the initial requirements were. So now here we are today. This is actually on the assembly line. We have a Raspberry Pi with a monitor that shows the operator's dashboard, so they can see what their consumption is at their particular line. And also it gives us the ability to do qualitative analysis, which is important with data science. And you combine the qualitative and quantitative. So it's basically not just the machine making the decisions. You need the human touch, the human element to use the machine as a tool to help them make good decisions. Here's some, at the end of January, so we looked at our air compressors. We had started shutting those down during non-operational times because we had some air leaks. So you can see the peaks and increases when we produce. We can actually download reports by the hour and see how much each particular asset used or consumed in energy for that hour. And we just enter a kilowatt hour cost, and we're able to capture that per asset. So, it's good when you have these $3 million ovens that we want to see this batch process produce. We send 800 parts through there. If we know for a 4-hour time period how much energy we consumed, you can calculate that to figure out how much each unit costs to produce an energy. Here's an example. I just ran a report just so we could see it. There's the kilowatt usage, the hours. I just put 8 cents as the unit cost per hour, so we can get a total cost. And we believe that will be helpful for our accounting department for like costing and doing that type of analysis. Here's an overall architecture of our vision, our plan, and it kind of combines our ERP systems, our build management system, which is open source, MindSphere, the energy monitoring application that we have, IIoT, so we've got a weather station that we purchased to install on top of the roof so we can start capturing that local weather data, which would be more accurate than 10, 15 miles away. We have our manufacturing execution system, so we're trying to develop, putting some sensors, working with Keyence and Siemens to develop an application to give us an MES because we haven't had one. And also it gives us the ability to pull in external APIs such as the weather data if we want to pull that in. And then we start thinking, all right, well, what's possible? Can this create new value? And given the previous research we've shown, you combine these and you're able to reduce our energy consumption, reduce costs, and ultimately reduce emissions. And what if we then take that a step further and actually start making predictions on how much energy we need in advance and provide that to our energy suppliers? Could that really help them because they can only get to level 1 metering. They don't have the valuable wealth of data that we have inside of the facility. So that's what we're looking to do is basically be able to provide predictions 2 or 3 days in advance based on our knowledge, and then give that to the energy supplier. And now that may not help them on a small scale. It may not help our single plant would not make that big of a difference. But if other people were to start getting involved with this, we feel like it could really make an impact on the environment. So. This is just an overall view of a data science approach. So we really look at descriptive, predictive, and prescriptive. So we want to see, what has happened in the past and what's currently happening. And once we can collect enough observations, we can start making those predictions. And finally, when you know what's upcoming, or you have a pretty good confidence of what's coming up, you can actually start making changes that will impact your forecast. So that's the prescription part, and that's what's going to be very important in the future. We'd ultimately like to take our build management system and automate some reductions based on the grid peaks. So as the grids are using more and more coal, for example, if we could work with our energy suppliers, then we could actually reduce that to reduce emissions. And we were, on January 30th, 2019, we were awarded the Green Plant label, successfully completed the project, and we're very excited about it, very proud of it, and it's just the way, we had a lot of road bumps that we encountered throughout our project, but we got through. So with that, I guess I appreciate your time.